Okay, the first example we're going to look at is parallelogram LMNP. Here we have parallelogram LMNP, and we're going to solve for x and y, and we're going to also state our geometric reasoning. Okay, so let's see here. We can tell from this situation that we have this and this, and according to our reasoning, we know that those two sides are going to be congruent if this is a parallelogram. We've also learned that the other pair of opposite sides would be congruent. So that means that this side and this side, or those measures, would also be equal. So in a parallelogram, opposite sides are congruent. That's a property. So as a result, I'm going to put something under my writing here a second. I don't have a bump in the table. So that means here that 9x minus 25 has to equal 8y plus 7, and that 6x minus 16 has to equal 5y plus 7. So we have two different equations. We see that both equations have x and a y in them. So we have a system of equations, two unknowns. We can't solve either one already for x or y, so I think I'm gonna go ahead and get x and y together on one side. So let's see, if I move this over, I get 9x minus 8y equals 32 when I add the 25. This puts it in standard form. And 6x minus 5y is equal to 23. So I have two options. Let's see, I could do substitution method, which would mean solving for one of those variables, which doesn't look like it's very pretty. 32 is divisible by 8. I guess I could do that, but 23 is not divisible by either one of those. So that's one option. Or I could do the linear combinations method. So if the linear combinations method, I just need to put them two together. I'll bring this guy over here. 6x minus 5y, it's also called the eliminations method. And the point is to get one of the variables to eliminate. So I think I'm going to go for the x's. It doesn't matter. I could have gone for the y's. Both of these go into 36. So if I multiply this by 4 and I multiply by 6, I would get 36 up here. However, I also want one to be positive and one to be negative so that I can just add them. So I think I'll do bottom by negative 6. So distributing this becomes 36x minus 32y is equal to 4 times 32, which is 128. The bottom, careful, we're multiplying by negative 6, so it becomes negative 36x plus 30y equals, and that's going to be a negative number, negative 138. And so now when I add these two, these x's will zero out. I'll be left with negative 2y equals negative, oh, that's convenient, and y is 5. So I have my y value. So one of the things that I'm looking for, I have. How do I find x? Well, it's a substitution. I sub in, and so I have lots of options. I can sub in into this equation, into this equation. I could substitute into either one of the transformed. I could technically use these up here. So it's just a choice. For me, I'm looking at going, well, I got to multiply 5 by 8 versus multiply 5 by 5. I think I'm going for that one. Doesn't really matter. So I think I'm going to use this one. and go, okay, 6x minus 5 times 5 equals 23. 6x minus 25 equals 23. 6x equals 48. X equals 8. Of course, I can check it, because when I check it, these two quantities better be equal, and these two quantities better be equal. So here I could say 6 times 8 minus 16 is 48 minus 16, okay, which I believe comes out to be 32. And 5 times y plus 7 is 25 plus 7, which is also 32. So those are both 32. So those are probably the correct x and y. Chances are they don't work there, they also work there. But just to make certain, 9x, so 9 times 8 minus 25 versus 8y plus 7. So we're talking about 72 minus 25 versus 40 plus, whoops, I don't need an extra set of parentheses there, plus 7. This one's 47. And I believe, yep, that one's 47 as well. Okay, so that works out. And so the answers for x and y are 8 and